Hello and welcome to this lecture where we will introduce the Amazon Simple Storage Service, commonly known as S3. Amazon S3 is probably the most used storage service that is provided by AWS, simply down to the fact it can be used for many different use cases and called upon by the many different AWS services. So Amazon S3 is a fully managed object-based storage that is highly available, highly durable, very cost-effective and widely accessible. S3 is also promoted as having unlimited storage capabilities, making this service extremely scalable, far more scalable than your own on-premises storage solution could ever be. There is, however, limitation to the individual size of a single file that it can support. The smallest file size that it supports is 0 bytes and the largest file size is 5 terabytes. Although there is this size limitation on the maximum file size, it's one that many of us will not perceive as ongoing inhibitor in the majority of use cases. Okay, so when the data is uploaded within S3, you as the customer are required to specify the regional location for that data to be placed in. By specifying your region for your data, Amazon S3 will then store and duplicate your uploaded data multiple times across multiple available zones within that region to increase both its durability and availability. For more information on regions, availability zone and other global infrastructure components, please watch the AWS documentation. And objects stored in S3 have durability of 11 nines, and so the likelihood of losing data is extremely rare, and this is down to the fact that S3 stores numerous copies of the same data in different availability zones. The availability of S3 data objects is currently 4 nines, 99.99%, and the difference between availability and durability is this: when looking at availability, AWS ensure that the uptime of Amazon S3 is 99.99%, and to enable you to access your stored data, the durability percentage refers to the probability of maintaining your data without it being lost through corruption, degradation of data, and other unknown potential damaging effects. When uploading objects to S3, specific objects are used to manage your data. Okay, so to store objects in S3, you first need to define and create a bucket. You can think of a bucket as a parent folder of your data. This bucket name must be completely unique, not just within the region you specify, but globally across all the other S3 buckets that exist, which there are many millions. Once you have created your bucket name, you can begin to upload your data. You can upload your data directly into that bucket, or you can, if required, create folders under your bucket to store your data in for easier management. By default, there is a limit of 100 buckets, okay, that you are allowed to create within your AWS account, but this can be increased if requested through AWS. So objects that are then stored in these buckets have a unique object key that defines the object across the flat address space of S3. Although folders can provide additional management from a data organization's point of view, Amazon S3 is not a file system, and so a specific feature of Amazon S3 work at the bucket level rather than a specific folder levels. Let's now take a closer look at the some of the features offered by Amazon S3, starting with an overview of the different storage classes that are available. So these are the number of different storage classes within S3, all of which offer different performance features and cost, and it's down to you to select the storage class that you require for the data. These classes are as follows: standard infrequent access, intelligent tiering, one zone infrequent access, and reduced redundancy. But this reduced redundancy option is no longer recommended by AWS, and I will explain why as we go. It's best to review the differences between these classes from within a table to enable you to understand the key points of the differences. Now, as you can see, the main differences between the classes is the durability and availability percentage that each classes offers. And to help us look at the differences between these classes, we can split them into two different categories: data that is accessed frequently and data that is accessed infrequently. Okay, so for data that is accessed frequently, you have two options, either standard or reduced redundancy storage, that is called RRS. The default storage class option for your objects is a standard class unless you specify otherwise. The reduced redundancy storage classes is an older storage class option and is no longer recommended by AWS, as the standard storage class is now more cost effective and offers greater durability for data that is accessed infrequently. We have looked at a standard IA and one zone IA, although they offer the same speed of access as the standard. This infrequent access storage classes charges an additional cost to retrieve and access the data. So the data in these classes are typically long live data objects that require very little need to be accessed. The difference between the one zone IA compared to the standard IA is the durability aspects. One zone IA does not replicate its data across multiple availability zones, and so only offers 99.5% availability SLA. With this in mind, it should only be used for data that can reproduced between standard IA and one zone IA. One zone IA is the cheapest due to its limitation on a single availability zone. Okay, so finally we have intelligent tiering storage classes, which is great for unpredictable access patterns, and this has the ability to optimize your cost of your storage by moving data object between different tiers based upon its uses. Intelligent tiering will move data between two tiers, a frequently accessed tier and a more cost effective infrequent access tier. If data has not been accessed for 30 days or more, than intelligent tiering will move data into the infrequent access tier. The next time this object is accessed, it will be moved back into the frequently accessed tier and the 30-day timer will be reset. So there are no retrieval cost. Uh, there are no retrieval cost for your data like there is the standard IA and one zone IA. However, do be aware that there is a small monthly cost associated to each object that is monitored by the intelligence steering classes, and each object must be larger than 128 kilobytes. Okay, so before selecting your classes of your data, you really need to asking yourself the following questions: how often is data likely to be accessed? How critical is my data? How reproducible is the data? Can it easily created again if need be? So, and do I know the access pattern of my data? When looking at the data within your bucket, the S3 console will also show you which storage classes that the object belongs to. Amazon Glacier is another storage class. However, it is also a separate service to Amazon S3. There are interaction between the two services where S3 allows you to use lifecycle rules to move data from S3 to Glacier. As the standard storage classes for archival purposes, but I shall cover more on Amazon Glacier in the next lecture. Let me talk a little bit about different security features offered by the uh, S3, starting with bucket policies. Bucket policies allow you to impose and set access controls against who or what can access the data within a specific bucket. The policy itself is written in JavaScript object notation known as JSON, and these policies are very similar to identity and access management. However, they only control access to the data and the bucket that the policy is associated to. More information and an identity access management policy can be you can read on the Amazon documentation. Bucket permission can be very detailed and a specific, allowing only access for a specific user within your account to access the data within the specific time range and only when coming from the specific IP address. As the example shows, there is a huge amount of granularity that can be assigned within these bucket permission. Okay, so access control list or ACLs are again another method of controlling who has access to your bucket. However, they only control access of user outside of your own AWS account, such as access from other AWS account or public access. ACL are not as granular as bucket policy can be, and so the permission are broad in access. For example, list object and write object You may be familiar with the number of recent security instances in which huge amounts of data have been unnecessarily exposed on Amazon S3 because the owner of that data failed to restrict public access to these buckets, which may have contained personally identifiable information. Understanding who has access to your buckets and data is essential when using Amazon S3 due to the potential of it being accessible across the internet. Okay, so data encryption, S3 offers a number of different encryption mechanisms to allow you to able encrypt your data. These methods cover both server-side encryption and client-side encryption options, which include server-side encryption with S3 managed key, known as SSE S3, server-side encryption with KMS managed key, known as SSE KMS, and KMS is the key management services. So more on information you can on KMS can be found on Amazon documentation. Server-side encryption with customer managed key known as SSEC, and then we have a client-side encryption with KMS managed key known as CSE KMS, and finally client-side encryption with customer managed key known as CSEC. The main difference between the client server and server side encryption is the location at which the encryption takes place. Server side encryption takes place within the AWS S3, and client side encryption occurs on your client prior to uploading your objects. So S3 also fully supports encryption in transit via SSL secure sockets layer. I now want to discuss a couple of features relating data management. Versioning, then you when you have enable versioning on a bucket, it allows for multiple version of same object to exist. This is useful to allow you to retrieve previous version of a file or recover from some accidental deletion or indeed intended malicious deletion of an object. Versioning is managed and created automatically by the bucket. When you overwrite the same object for easier management, S3 will only display the latest version of the object within the console, but it does provide a way of viewing all versions as and when you need to see previous versions. Versioning is not enabled by default. However, once you have enabled it, you need to aware of two main points. Firstly, you can't disable versioning. You can suspend it on the bucket, which will prevent any further version from being created of your objects, but you cannot disable it altogether. Secondly, versioning will be an added cost to use you as you are storing multiple versions of the same object, and the Amazon S3 cost model is based on actual uses of data. Okay, so Lifecycle rules AWS provide an automatic method of managing the life of your data while it is being stored on Amazon S3. By adding a lifecycle rule to bucket, you are able to configure and set a specific criteria that can automatically move your data from one class to another, move it on Amazon Glacier, or delete it from Amazon S3 altogether. You may want to do this as a cost saving exercise by moving data to a cheaper storage classes after a set period of time, for example 30 days, and once those 30 days are up, Amazon S3 will then automatically changes your storage classes of that data as per the lifecycle rule. Another example would be that you may only be required to keep the data for a set period of time before it can be deleted, again saving you money on a storage. In this scenario, you can set the bucket's lifecycle policy to automatically delete anything older than 90 days. For example, these time frames are up to you and your own set requirements. Let me now talk about some of the common use cases of Amazon S3 that are used by many organizations. Amazon AWS is commonly used in a number of different use cases due to the features I have already discussed, making it widely accessible and usable for different data types. So let me now just cover a few different scenarios where Amazon S3 would be a good solution for your storage requirement, starting with data backup. Many people find that a highly scalable and reliable component of Amazon S3 an ideal choice to store data backup, either for existing AWS resources that you are using or for your own premise data. AWS offers solution to help you manage the transfer of your own premise production data to Amazon S3 as a backup to your primary storage on site. Later in this course, I will discussing methods on how this can be achieved with its ability to scout enormously and the flexibility of being able to retrieve your data with ease. It's easy to see why S3 makes a great data backup solution. When your data is stored on S3, it can be permission allowing, accessible from anywhere you have internet connections if required. This is another reason S3 makes a great service for data backup solution, allowing you to retrieve your data from anywhere should you need to access it. So static content and website. Um, S3 is perfectly for storing static data such as images and videos which are used on almost every website. Every object can also be referenced directly via a unique URL or by the content delivering network such as Amazon CloudFront, which interacts closely with S3. If your website is entirely static, then your whole website can it fact be hosted on Amazon S3, providing a highly scalable and cost effective method for running your website. I will cover Amazon Cloud Front later in this course. However, if you need any additional information on both Amazon CloudFront and running the static website within the Amazon S3,